So, 2-minute intros on me. I'm going to throw a few random things at you. And then we're going to talk a little bit about engineering culture, code, and process. My particular aim, I'm always thinking about where's the appropriate feedback loop. So when I say feedback loop, it's not a hashtag for me, it's a real thing. It extends beyond technology. It goes into people and process. So that's what right-fitting feedback loops is. And then we're going to spend the better part of a half an hour at least doing what I call hive minding, which is exactly what I discussed here. Okay, so let's get a few things out of the way. My name is Paul Bruce. I work in a couple of communities in the Boston area. I am the director of customer engineering at a small little company up in Lexington that I work with. I also have my own little LLC to do cool and interesting things on the side, one of which you'll hear about later. I also dip my toes in a lot of pools. I keep my fingers on pulses, and one of the things that I realize is that there are standards bodies out there for reasons. Questionable, better, worse, I don't know, but I'm interested in what they're doing, especially around DevOps, because I care about DevOps and I don't want people to mess things up. And so I also do a lot of automation engineering, and I also care deeply about product strategy. Not just are we building it right, but are we building the right thing? Verification and validation. That goes all the way up the stack in an organization. It's not just testing. And we'll get to Observe 2020 later. So I have very few real credentials. I'm a self-learned. I remember the first time a computer spoke to me was when I was 9, and I had my dad's IBM XT open to the world. These are the big hunkin' old computers. It was a clone. I started prying chips out and then turn it on, and I would hear opcodes, beep codes, that told me what was wrong. I didn't know that at the time. I just thought it was speaking to me. Like somebody had done something in there for me. And so I got excited about that. By 13, I was tearing apart websites on GeoCities, and that's where this comes from. At this point, I was building apps in JavaScript for Netscape Navigator like 2.0 that would tax the crap out of those browsers, right? Those early browsers. Because I didn't know any better. I didn't know to optimize my stuff. I just knew I could build stuff at the time. And then I worked a lot in various different companies around this area, in various different jobs, mostly development. So I come from a development background. And now I get to do really cool things, like I said, in customer engineering. And if you want to know more about what the hell customer engineering is, let me know. Because is it customer focused or is it engineering? Interesting. These slides are also here, so don't worry about that. This is public knowledge, sadly, at this point. And a few things I want to throw out there. So this talk is, I think I got enough people to show up because they're wondering if, putting that in my pipeline and smoking it, smoke testing it, was actually something coming from somebody who would do that. I don't particularly care about that. I have 2 kids. I don't have time for that kind of stuff, right? I travel all over the US to work with clients. And so I'm deeply excited and also deeply concerned about some of the patterns that I see across a distribution curve from everything from small companies to like the Fortune 50. And I work with all those kinds of people. So I think I'm a performance engineer. So everything to me is like a distribution curve, like a bell curve. And it's like, what part of the bell curve are you talking about? Are you talking about devs? Are you talking about dev test? Are you talking about test? Are you talking about, what part of the business are you talking about? And to me, what I see is that there's a lot of people building a lot of pipelines, these things that take some idea, the implementation of it, and put it through a process to make sure that it's not broken as fuck. And I probably should have had a parental advisory warning, because I apologize if you're put off by words. But I have some words that are good and some that are not, so that might leak out. So pipelines are a mess right now. I don't mean that there's one way to do things. I mean that there's a million ways to do things. And the good news is the tools and technologies are getting better, right? We have everything from cloud-based pipelines all the way down to like local, build it your own, do it your own. I work with quite a few of the major ones, certainly in the Fortune 100. I spend a lot of time in Jenkins, sadly 2.0, and yes, sadly 3.0 as well. And then also a lot of Azure DevOps, surprisingly, hashtag put something on your product, and then it becomes DevOps. Then also a little bit of Go. Let's see, what else? I sadly had to dip my toes in TeamCity a little while back. And with all these different types of systems, right, Go CD, GitLab, I'm looking for what is the core fundamental, right? What is what I have to help people with to articulate into a pipeline where it's the least amount of resistance to get that thing working and working reliably. And like I said, I'm a performance engineer, so part of my job is load testing, right, and performance engineering in that way, putting pressure on systems. And that is not a tricky thing to just stick into a pipeline. A unit test works pretty much everywhere, similarly or the same way. What about your performance tests or your security tests? We're all familiar with integration tests, and those are hard enough to get working locally, and then you have to get them working in a pipeline. I'm beyond that. I'm doing load testing, right, on a multiple times a day basis, nightly builds, putting the pressure on the system to always know what the baselines are of what you just built, right? So that's the kind of bizarre and twisted things that I have to stick in a pipeline and smoke test it. So the other thing is the pipelines, they can leak, right? They can leak things like bugs, right? Coverage, not 100%. What is that even, right? That's a fallacy. That's never going to happen. But at least what you're trying to do is get baselines, get consistency, make sure that these things are working as they were supposed to yesterday, today, with code changes. But they also leak other things. And one of my other heart groups here is the DevOps, the Boston DevOps community. And we have done a number of talks around things like security. And what we find is that pipelines, if that's like the parent of your process, right? That's like a person on your team doing things all day long, and you stick security credentials in there, right? You have secrets in there. And as it turns out, pipelines are some of the worst vectors of attack when somebody actually gets into your organization, because it has all the keys to do all the things, or enough things. And so secrets in a pipeline leak out a lot as well. But there's so many options on the market. The other completely separate concept, just pausing for a second and saying, what have we done? Code, and yes, APIs and command line interfaces are now the modern norm, right? That's how we do our job. Yeah, we have some IDEs that simplify our life. We've got a lot of tools that do a lot of stuff for us, but a lot of the stuff lives in a pipeline as code, because the thoughts in my brain only exist in my brain until I articulate them into something. And why am I doing that? So that it can run reliably. It's one thing to share this with another person on your team, and maybe it works on their machine. It's another thing to actually articulate in a way that a machine that doesn't care about who you are, what kind of day you had, right? It's still going to run your code, not just your app code, but your process code, your infrastructure's code. And our landscape is full of awesome as code solutions, where we stick our code. Sometimes it's local, sometimes it's up in cloud. Then there's also things like how to describe your APIs, right? As Swagger, more appropriately, Open API. I basically live in YAML all day long. We've got things to deal with testing as code. Selenium scripts are test as code. So is things like Espresso for Android devices and XeTest for iOS devices. Those are more specific, less black box, out of the box than Selenium. There's benefits and drawbacks. Then there's things that are a little higher up, like business-related articulations, given when thens from Cucumber and Gherkin. Right? These are all code. We also have things like network as code. There's a couple of links, by the way. Like I said, the deck's here, and there are oftentimes notes about links to some of these things. There's Cisco DNA, which describes a network and a network configuration. We're not even talking about like cloud stuff. We're talking about like on-prem stuff. There's F5 Networks that has an infrastructure as code. One of the guys, Tom McGonigal, who is in the DevOps group as well, he's active in that community. He did a lot of work around that. We have stuff to build your system, to deliver your system. This is all code. Then what your system is described as at this point. What is a system? Does it have to be a whole hunking from the ground up physical hardware all the way up to working software? No. Most of this is composable stuff like little containers that run in a larger orchestration environment. But they're all described as code. Kubernetes, how to make sure that those containers are delivered and deployed and operating reliably. And then you've also got even cool things like, it's not exactly code, but it's close. Open Telemetry is a new way to do distributed tracing. And it's an open source, it's in the Cloud Native Computing Foundation. And we'll talk more later about that if you want. In such a way where you could actually describe, this is the type of telemetry that I want out of my application, and it makes it very easy to switch providers, like how you collect it, how you consume it. But there's a lot of code in the world. So then there's people who like to automate all the things. And this comes from a lot of different places. It comes from, again, distribution curve. I'm somewhere on it as well. There's a lot of ignorance about what that really means, both at the tactical level, at the bottom of the stack, at an organization, and at a high level. But I think the goal here is automate as much as possible, because when you try to put yourself up to automation, it really makes you articulate what you're really trying to do. You don't have the luxury of being wishy-washy, or maybe not doing it one day or doing it the next in a different way. So I like the idea of automate what can be automated and automate as much as possible, but that depends. And so this whole all the things thing is more like this. When you get to the point where you're actually an engineer and you get some mandate to automate something that you either don't know how to do, you look online and there's absolutely no precedent for it, a little like that. And so, I see, have you ever seen the t-shirts that say this? I'm not gonna name a vendor, but this is something that is like marketing bullshit. Test all the things. That's a nice hope, but it's not a strategy. Try to operationalize test all the things. You can't do it. The hope is not a strategy is one of the first things that they say in the Site Reliability Engineering Handbook. And even if you don't think you're involved in reliability or performance, read this book, because there's a lot of great information that helps you have empathy and understand what happens after. What happens after you're done with your test, what happens after you're done with your dev, and vice versa. This is about making stuff work for real. And yeah, it's based on Google, and we're not all Google. Some of us don't even want to be, mostly. But that still doesn't stop them from publishing really good ideas. I get a lot of really good ideas from my kids as well. So this is not a reality. This is not something that you can put in an organization and watch it work effectively. There we go. Oops. The other thing is, sadly, I was at Jenkins World for how many times now? Consecutively. And the after party, they basically had a table on the side, like everybody goes and gets free drinks and stuff. And on the side, there was this big table of all different colored capes. And the goal was to put a cape on and walk around, because we're all superheroes, right? No, we're not superheroes. Devs aren't superheroes, right? This is not a developer thing. Test engineering are not superheroes. Managers are not superheroes. We are not superheroes. If you don't believe me, follow that link and you get spoken to by somebody. But the problem is, this has went its way into the marketing and the vibe that we have to be, right? When we save the day or when we do after hours work, right? Or when we go overtime, that's not always fun for us, right? Sometimes at the end you solve the problem and you're like, oh, thank goodness, right? And then you go home, or then you go on to your other thing. But the problem with a superhero is that they're a single point of failure in the organization. And if you read something like the Phoenix Project, which is a kind of a narrative around what was broken about the old model of doing things, and maybe why some of these concepts that come from, amongst other things, organizational theory and DevOps, that these are things we have to really pay attention to now. One of the problems is that one of the the contributors that solved problems, right, when things came up, was a developer that knew how to do all the things. The problem was, he was the only one that knew how to do all the things. And so that single point of failure produces, it's an anti-pattern, right? And so that's why I say we're not superheroes. What we are is engineers, hopefully, right? And at the very least, rather than trying to avoid problems, which I know problems come up and there are things that you want to avoid today, we work out what's going on by understanding why it's going on, right? This was a guy I met in an airport. I just had to stop and appreciate his t-shirt. It said the engineer's motto is if it isn't broke, take it apart and fix it. That can get you into trouble, but the spirit behind that is, I don't care if it's working or not. I want to understand that thing. Because on the moment, on the day when it's not working, somebody has to understand it. So, this thing here, does it look waterfall to you? I just put that out there. This is a feedback loop. Right? Get your requirements under order, and then start working out how to go about that problem, how to tease the thing apart and figure out what works. So I think rather than avoiding problems, we need to face them and address them for real. That's what an engineer does. The other three things that I like to think in my mind when I think, how do I describe what I do to like family and friends as an engineer is that I am curious. A good engineer is curious about things. Doesn't mean you're going to act on it, but you always have a sense of curiosity. Well, what? What did you say? Right? How's that working? What's going on there? Obviously, engineers have to be very proficient at things, but they know from curiosity that just because you're not proficient at something now doesn't mean you can't be. Right? You can take that thing apart and fix it. And the third thing is, a good engineer understands the constraints that they have around them, the environment that they live, the human environment, the technical environment, the organizational, cultural situations, behaviors, right? You have to be aware. That's what curiosity does for you. It hopefully makes you more aware of what's going on around you, right? So that when you get to the point where you're like, well, I can't do all the things, you have a sense of what other people think are useful and important, and you can start to align your work with that, and vice versa. Maybe do that, and they'll start to align their work with that. So in terms of that, going back to that notion of code, right? From an engineering perspective, if I frame this enough to say curiosity, proficiency, and priority, code plays into all those things. Mostly what I like about code is that it brings details out in the open. Right? If it's in a repo, and you can look at that code, even if you don't totally understand that language, you can start to ask people, what does that mean? Why is that the case? Right? So there are plenty of systems that you don't have access to the code for, and all you have to do is black box test it. Right? You have no idea. You just got an interface. But we're seeing that change, and certainly in the organizations where it's like, these roles are blended. You do half your time in dev, half your time in test or something, which could be idealized. The point is, if you don't have access to see into that system, you can't exercise that curiosity, which has a negative downstream effect on all these other things, right? Prioritization. Skipping past a few things, the proficiency. So a proficiency of code is that the information is out there, right, in a way that is typically, in some way, either executable or is interrogatable, right? And so you can look at what dependencies the software has. A lot of what the security and threat analysis software now does is looks at some of the dependencies that go into the software. It doesn't just dynamically test it from the outside. It actually looks and figures out you've got vulnerabilities. If you've ever gone on, if you go on PyPy or if you go on NPM, or heck, if you check stuff into Git, I've got stuff from in Git from like 3 years ago. It's got all these vulnerabilities. I'm like this close to just pulling it out because I don't have time to fix it, and it's like nobody cares. So at that point, that's because the code was out there in a way that could be navigated over with better tooling, with more automation. And it also surfaces assumptions about things like number of people who actually work in the Docker space. anytime something starts with :latest, like start your base image and just use the latest of whatever they published, is a scary proposition. When you're building your own containers, you don't want to be subject to today's build inheriting an entirely new update, which might be nice because they patched something, but you know what it's like to walk in and an update, maybe to your operating system or to, to Selenium, that really fucks it up for you. And it takes a while to figure that out. Maybe you got to start figuring out which dependencies to not include just to get that test suite to work. So you don't just want to inherit whatever's coming from the open public web. And this is one of the things that, like, I can easily scan for any of our images in Artifactory that start with a :latest. It's assumed that that's going to be pulling from whatever's latest. That's not necessarily a pattern I want to adopt for particular parts of my business. Right? I want to make sure that I'm on versions that I know that's the version that I was based on. I will upgrade and update the versions as I see fit when I have time to do that as soon as possible based on risk and organizational strategy. In terms of prioritization, right, how does code help you prioritize? I think first off, it does, if all your testing stuff was, if as much as possible is in code, right, is it an executable, not only does it inherit the benefits of being able to be automated, but it also allows you to treat it like other work, right? Like the same type of work as dev. And so when we talk about tech debt, it covers a lot of things, but oftentimes unless you can quantify something, you can't really chalk it up to tech debt. You can't quantify it, so it doesn't exist. And so I'm saying, like, if there are specific things that you need to test for and they're in code, they're almost the same exact thing as having app code out there. And so just like we can reason about tech debt because we can quantify it for code, for app code or service code, the same way we can do with test code. Now, we would like to think that the world is deterministic. We'll walk around with blinders on. But in reality, if anybody has ever run more than basic unit tests, we know these systems are not deterministic. And I don't just mean flaky. I actually mean today's data doesn't just not work, it actually breaks the system for the other tests that ran fine yesterday. I've seen that plenty in the insurance and surprisingly in the cellular plan business, right? Cell providers, they have massive amounts of data that they have to regression test just to make sure that the plan they sold you 3 years ago that you're still on, that's not as good as a plan somebody else is gonna maybe get like as a new customer, but that still works exactly the same way throughout all these complicated billing systems. So the data itself causes sometimes determinism to go out the window. But if you've ever heard the statement like, quality is everybody's responsibility, bullshit. I mean, yes, sure, idealistically, yes. But when you start to get down to the tactical activities, how you break this out into work streams and swim lanes, it tends to not get, this person over here has to think about the holistic system. In fact, that would be an anti-pattern to be able to do things quickly and efficiently. And so from an idealist, I'd rather say something like everyone contributes to the final quality of the product. The product owners, above the product owners, how your business is actually being run. What decisions, for instance, mabl was making when they were launching, right? Before they were fully launched. And now what they're doing now. Those decisions have an effect on what that team does and how they do their work. Then you get past the product management and you start working out development tasks, implementation tasks, you start bringing in people from different parts of the organization, and that's where decisions, especially decisions that are less informed by proper information, can start to affect the quality of the product. So I also think there's a couple of platitudes I won't pull out here. One is everyone is required to not add toil. Anytime you're doing something that you can qualify as this is toil, this is something that I will have to do again and again. I'm not adding value to myself, to the team, to the organization by doing this again and again and again the same way, right? Writing checks for people in an organization has value. Making sure that that's as fault-free and as quick as possible is a payroll's responsibility, and that adds value to the organization. That's not Toil. There are some marginal things that they want to improve at a particular level, fine. What I'm talking about is things that you're pressing the same button over and over again, and either you haven't like sort of rallied to the rest of your organization, or you haven't quantified how much time is wasted by that thing. Right? That's what I mean by Toil. Stuff that's not repeatable yet. That's a given. Everybody's negatively affected by bad releases. I mean everybody's paycheck, whether you feel it now or in a couple months. Everyone that produces code, right? So anytime there's a test that is code, that's involved in a working pipeline. If the test is broken and you're the only one that knows how to fix it, then it's either going to get turned off, right, disabled, which is not a good idea, or somebody's going to have to toil and figure out what's going on there if it's not clear and clean. So everybody who produces code is part of that pipeline, and everybody is part of the software delivery process. So I've used the word a couple of times, process. This is not the parental advisory warning I was talking about. That'll come later. To me, process is not a dirty word. I'm so sick and tired of people lumping. We're not a heavy process company. I'm cool with that because that's a different word than process. Process matters, right? Process is the articulation of something that's supposed to work a certain way for a certain set of reasons, right? And since I'm in the DevOps space, I have to do a lot of reading, and since I'm curious, I go deeper in sources. And one of the sources to the Phoenix project and the DevOps handbook and stuff like that is a guy named Eliyahu Goldratt. And he wrote he's in the organizational theory and theory of constraints. Very good thoughts. But his book, The Goal, was, again, a narrative about what is an organization, how is an organization supposed to function. It's actually worth his lectures, which is the Beyond the Goal book, to actually listen to this. I don't care whether you work on one or both, but please listen to either or. And my preference would probably be listen to some of the lectures Beyond the Goal, because he cuts right to the quick. He gets right to it about a couple of things. And if you think about this, in these books, he talks about a process, just as important as like a new technology. What do you think technology is? It runs on computers. It's a process. It's just a product at the same time. So are the processes in your organization. Yeah, they need to change sometimes. Yeah, they do their job sometimes. But it's a thing. And when it's quantified, you can reason about it, and you can work with it. Even a human being's creative capability is a process. Read the Creative Thinker's Toolkit. This guy walks you through how to exercise your creative muscle. It's not something you're born with. Some people are better at it than others. Fine, there's inherent capabilities. But there's plenty of stuff that you can improve on in terms of being creative, thinking creatively, and helping other people think creatively, which is part of where some of the group thinking will come from later today. So I know we're a little bit on time, but I promised myself I would read this verbatim. About risk and about loss, but about gains. So some people like to say things like reduce toil, and some of my DevOps cronies, they'll recognize the radiate information. I don't need more information in my life just for information's sake. We're drowning in information. I mean, you can build a great pipeline. You can build all the tests. You can put things like Capital One had a platform. Shoot, it's escaping me. Hygieia. It's like an open source sort of thing you can plug into your pipelines and start to measure the efficiency of different teams and different builds and stuff like that. And that's great. And you need to summarize information in order for it to be really effective. So for the reduced toil, I don't think that's enough. I think it needs to be treated like a disease. When something is toil, we need to prioritize making it not toil so that we can move on to the next thing. And maybe that next thing is a different toil, and we fix that. But eventually you get to the point where you can actually focus on stuff that's actually building value into your organization. And in terms of radiate information, I think a better articulation of this is feedback loops. Find where a feedback loop makes sense, or figure out with your teams what type of feedback matters at what time, with what context, right? So that's why right fit is such an important part. You don't just install feedback loops wherever you can. That's a waste of time. You really need to have right fit feedback loops. And there is intrinsic, they're intertwined. Feedback loops, the effectiveness of feedback loops, and the time budgets that we have. You cannot run all the tests every time you want to run a local build. You can't even do it sometimes when you do a pull request, right? You can't run all the tests. Eventually you would like to run all the tests, maybe. Maybe your testing strategy is before or after release. But the point is, it depends on the time budget you have. That is something that the business is never going to give you more of just because you say so, right? You have a certain time budget, so you got to figure out what feedback matters at the right times that fit to those time budgets. And these are just some suggestions of what would right fitting look like. You got to quantify the value of having that feedback as well as not, right? And just for the sake, if you haven't done exercises like this before, start just by saying, forget time. What are the things that are valuable so that you build the list? That's something out of the Creative Thinkers Toolkit, is the notion of divergent thinking to get some ideas on the table so that then you can converge on which ones are the most effective ones to implement. Cost of not having feedback, right? Downtime, those kind of things. If you can quantify it, actually graph out, just on the back of a napkin, right, with some information on hand, graph out the value, the risk, and the cost of a particular feedback, a hypothetical, we want to inject this feedback loop, project the cost and the benefit of having that there. So you can talk about it, so you can reason about it. And if there's not enough information on hand, somebody's going to go, that sounds good, get me some evidence. And so you can dig deeper. And more importantly, this is a huge collaboration. Everything we do is a collaboration with other people. So the first thing is, if you want to install a feedback loop, especially at a larger organization, and it's not just like 5 people or 10 people in an office or distributed globally somewhere, that can work too. But I work with a lot of very large companies, and so there's a lot of teams involved in the stuff I do. And you got to find early adopters of these feedback loops, because you might give them the feedback, and it might be just the right feedback for them. But you got to understand how that's interpreted, how that changes the dynamics, how that might play if it's so visible that it disrupts all the other things that that team is doing, right? They don't want to expose themselves to stuff they can't handle in a dynamic, but I'd rather make that information a little bit more visible and open so that people can make better decisions about that. So let's go back to test all the things, but let's revise it. So I've been working on building out essentially a Commandline Interface for load testing software that works in enterprises. And so there's all sorts of configuration, different types of deployments that you would have, but I want to make it so damn simple to run these things, because I'm sick and tired of writing a plugin for Jenkins, a plugin for TeamCity, a plugin for Bamboo, who even uses that anymore, I guess, I don't know. And plugins and helper functions and and I'm just like, if it was easy to use, we wouldn't need so many helpers. We wouldn't need so many plugins. So what I've done is I've written essentially a CLI for the software that I work with during the day. And I realized, obviously, if I'm going to put this out in front of customers, and even to folks like you, because this is not only pip installable, but it's also in Git. It's an open library. So I would probably want to test my own shit. So the good news is I do this all sorts of hours on planes, not so much with the distributed stuff or the checking in very large Docker images on a plane connection. That's a bad idea. But also things like nights and weekends, right? When I'm getting interrupted by kids, which is cool because I shouldn't be doing work at home, right? But gotta try something out for 5 minutes, and then also I like to have beers, and so like after one beer, I want to make sure that what I'm doing is still on par, that it's not gonna mess things up. And even if it wouldn't mess it up before I release something, I still don't want to mess it up for my future self 15 minutes later when I get distracted and I come back and I've lost context. Tests help you not fuck things up. So I have written a bunch of tests for the Commandline Interface, which literally exercises a black box, that Commandline Interface, which in some cases is very simple. Some is just informational. You modify some information to the API, that's fine. Other things are like, multi-stage process, attach some Docker containers, right? Kick off a test, detach them. I need to make sure that that thing works really reliably, because I'm bringing the execution and orchestration of this thing into a simple interface rather than having 30 different implementations of it. I have one, which again, remember superheroes, single point of failure? This is not a single point of failure if I don't test it, if I do test it, right? If I do test it, right? So that's just my current bag. And I also think that it's really important to prove that you ran your tests. Now, in very built-out systems, sometimes that's built in. Obviously, you report out your JUnit results or whatever, into whatever, barf it out into a particular pipeline, and that archives it as part of the test. Okay, fine. I'm actually committing all the tests that I ran to the repo, to the actual branch that I'm doing the work on, and they're just little text files. But they prove that it ran in CI. And I could run it locally too, but the point is, prove that you actually ran these tests, right? Some bigger systems, they allow for reporting and for tracking this in another way, but the point is, verifiable software also needs to have a verifiable process, right? And so this was my cheap way of doing that with this little Commandline Interface repo. And you can check it all out or talk to me afterwards about it. So there's three main questions that I really want to ask, and I've got a whole bunch of things that might be useful in terms of thinking. We'll come back to these slides later when we're actually doing this in a group, just for kind of reference, just to kind of spark your brain about it. But the first question is, why wouldn't we test this thing? Have you ever asked yourself that? Why wouldn't we test the stuff that we're about to ship? Are there problems? Are there blockers? First thing is, obviously, it's a question to incite the answer, right? And so, I would say, how important is it for this thing to work in terms of money? Actually, get down to brass tacks and try to figure that out. Just try, right? This is not a you have to do this. This is not my prescriptive. This is how you do software stuff. I'm just saying, try to quantify what would happen if you didn't test this thing. Skipping past. Things like project scheduling. Why wouldn't we test it? Well, was the appropriate time allocated for testing? Do we have all the things we need for the kind of testing, the environments? And do we have budget for the things? Aside from time and environments, which are kind of a derivative of actually having money for it. I oftentimes find in large organizations there's this huge new product gets pushed out. There was budget for that work, but then the maintenance budget for the thing goes to very little. And it becomes very hard to work into the maintenance budget of something, because even when you find a vulnerability or a risk, it's not been accommodated, it's not been dealt with properly at an organizational budgeting level. Then there's the what must we test, right? I really want to hear what you guys think about what must we test, right? Why wouldn't we test it? What must we test? Are there organizational risks or policies that are in place? That's important to me. If we think about, if we think we fixed something, how do we actually know that we fixed it? What have you done to prove that you fixed the thing after you've written a test, right? Is the test itself faulty? Do you positive and negative test? So the final thing is, this is kind of a statement to say, when you start to get really curious and you start to put the pressure on saying things like, why can't we test that thing? you end up with stuff like, for instance, the biggest problem that I ran into in 2017 was that there were mobile devices going on the market with features in the Android development kit that didn't also have comparative testing features for that feature. There was no way to simulate mobile, the fingerprints. So they were allowing people to develop and build this whole ecosystem that was not in any way testable. And that was Android's fault. That was Google's fault for shipping that stuff out, right? But, you know, as it turns out, that provided a bunch of vendors the ability to sort of inject fake fingerprints into their stuff and build some value on top of that, fine. But there was a gap when we had no way to test this stuff. And so it then became completely manual, which again doesn't fit into a pipeline, isn't automated. You have to deal with it and becomes a lot of extra work, becomes an extra cost to the organization. The assets that are poorly vetted but promoting into test and production, the story is somebody wrote some tests, they left credentials in there, the tests got inherited by another team that wanted to use them to test in production. And the same statements that now ran in new credentials that had too much power in production started deleting logs, started deleting records. So that's scary. So things have to be vetted. That's maybe why something might be a little hard to move to another test context, is because maybe it needs some vetting and we just don't have the time yet for that, but that has to be considered. And also, is it available for testing? I love this one, right? Well, the system isn't available, so I can't start my testing. What are you talking about? You can create test structures and text fixtures. You've got open APIs that describe, open API descriptions that describe the API that you can stand up mocks. And some of my work during the day allows me to be part of these large organizations that have taken on problems like this so much that they're like, why are we paying this thing that we don't use a lot? We could write something ourselves. And so this is actually an open source service virtualization tool. Like you could stand up fully, like highly performant mocks with this tool that comes from one of the teams that I work with. And I oftentimes give them feedback in the form of pull requests for that. So that's pretty cool. That removes the need to have necessarily the system online and available all the time, right? You can still run your test suite. It's not going to do the same as if you have the real system in front, but you can start earlier. That's a pretty well-known pattern. I will say there's a couple things that are purposely built not to automate. How do you test captioning? How do you test multi-factor authentication? I would love to hear the stories of how you figured out how to do that. Because usually these things are purposely made to subvert automation, robots, right? So it'd be very interesting to hear if you've somehow come up with a way to do that. My way is to, at least for things like ping ID, in large organizations, there's an exemption. You could just set a bunch of test users exempt from that process, and you're not testing ping ID. You're supposed to be testing the system under test. So just scoot past that like two-factor authentication for the testing purposes, because you're not trying to test the multi-factor authentication unless you really are. And then you're in another world of hurt. So what do we want? Testing. When do we want it? Well, it depends. And there's a bunch of other slides I won't go through, but this is not waterfall. This is a dependent sequence of events in terms of delivering things out to the market. Sure, you can start your tests earlier, but you can't actually expect money from customers who are using your software unless it's built or planned for. Does that? I mean, come on. There's a fundamental thing here. This is not a waterfall thing. This is a dependent sequence of events thing. And so with that, there's time budgets in various parts of that sequence of events. Doing unit testing, even typing into your IDE and scouring over an API, right? Autocomplete in IntelliSense, right? That's an early form of validation that you're on the right track. We'll then do your unit tests and your local integration tests sometimes, then you ship it up to a CI. And so there's different time budgets for those things. That's why you don't test all the things on your local laptop, not only because it's a bad idea, because various reasons like your laptop's different than operation, but the fact is that would take forever on a single computer, especially in performance testing. This is an example of just saying like this would be a strategy that one of the customers at a large scale might use to sort of make sense of when are we doing what and for what reasons and triggered on what ways and how long do we have for it. So I won't get into detail about that, but it's in the slide deck and talk to me afterwards as well. what I want to do with that CLI thing, one of the things I'm really excited for, is that the semantics on your workstation should work the same as what's in the cloud, what's in that pipeline, right? There are some CLIs, it doesn't even make sense. Saying that about like the AWS CLI, unless you have some fancy like on-prem version of AWS, I don't know, I don't. To run commands against Amazon, it's already in the cloud. But there are plenty of things that we can do, just like unit tests can be run locally and also in the pipeline, maybe at different amounts and volumes. The same thing for me with load testing. I want to be able to kick off this test, make sure it works a little bit from a local workstation so that when I check in that code, it goes into a pipeline and it actually runs at a little bigger scale and then a lot bigger scale, that there's no obvious flaws in that thing. So that's my goal here, is to really transcend the only place that it works is in larger systems, is to be able to actually articulate this and run it on a dev workstation just easily. There's a couple of thoughts about speeding test creation up. Putting it in code makes it easier to collaborate with. There are multiple people that can help you with that in your organization. Also, there are some patterns like, well, the devs don't want to deal with that type of testing, but we'll create some kind of intake form or some kind of intake process that automatically creates test structures that are like the start, right? And then other teams who layer in more considerations and context, they can move from there. But there's a lot of things that can speed up test creation, and service virtualization is also another great thing for integration mocking. I think what will speed up test creation most is having the right things in the definition of done or in your PI process, right? Having people at the table that could ask the question, why aren't there any performance criteria on this? I've done a lot of work with teams to figure that out as well. My goal is, yeah, sure, test it locally, absolutely, but always do everything else in a pipeline, right? As much as possible, make sure that that's off your system, that that's in a different context that also can scale. And my journey about this says secrets, right, are a bad thing to just have lying around everywhere. So secrets have to be outside the repo, obviously, but also working with technology right now called Vault to try to basically do away with all of the secrets in pipelines that I can possibly find anywhere. The source code has to be in a repo, obviously. You're not going to like email it to the CI system, so it has to be somewhere central. The test process as code, an example would be the Jenkins file, and I can pull up examples later afterwards. And then also, I found that you branch off a little bit, you do some work. Branches should be short-lived. I'm a big fan of the trunk-based development, but like do your work on the side. The branches help you then go to your CI system and only test your version of that thing, right? And so then, rather than it being a big test, you can do tiny little changes to both the test code and process. Try that in that branch, specify the branch modifier in your CI, and then actually be able to run just that version of not only the test code, but the process of executing that test code, so long as your process itself, your build process or your testing build process, is articulated in code. All the things that work in the test suite should work the same for your machine, right? At small volume, within reason, but it should be able to transcend those environments. Right? Otherwise, it's not articulated in a way that other people can port over their machine or over to their CI system, right? It's less portable is the point. So you really want to make sure that it, as much as possible, works on your machine, works in a CI system, works in potentially multiple contexts. And if all else fails, really try to put it in the pipeline, right? If you don't believe any of this stuff, that's fine. But just think about the processes that you have on hand, some of the stuff that you're just like grunt work, like Toil, right? Just think about what it would take to put that thing into a pipeline. And think positively about it. Give yourself like 10 minutes to think positive about it and be the protagonist of that, and then you can get back to the antagonist, right? Then you can be like, it's not going to work. But at least give yourself the opportunity to try it, and I would say, if you try to put it in a pipeline, you'll figure out what the constraints are, and you'll be able to articulate that to your team, to your organization, and you'll be able to say, these are the real reasons why we can't test it, not just because we don't have time for it. So with that in mind, there's a few shout outs, and then we'll give certainly some time for a bathroom break. And then when we come back, I would love to do some hive minding. So quick shout out, Boston DevOps community. I have been very excited to try to figure out how to blend testing into a lot of the stuff that we do in the sysops and cloudy stuff there, but you're more than welcome to come. Please come and visit if you haven't already. And that's another community, and I see some cross-pollination already. The other thing is these two links, especially with the Slack sign-up, took me a little while to figure out how to make sure that robots can't get in there, so that's untestable via CAPTCHA, so it's a little reverse thinking from earlier. And then also DevOps Days Boston 2020 is coming up. I'm one of the organizers. There's a whole group of us, 6 of us, that really work very hard to try to make that event. We're always interested in volunteers. We're always interested in new people to that table as well. So if you're interested in volunteering, please, it's a fun time. It's fun and wild, and the CFP and tickets likely to be determined, but on the other hand, we know that we've locked in the venue for September 28th. So we'll come back to the notion of like when exactly the CFP might open when we can. We also did a little bit of work with Resilient Coders in that event to provide an academic sponsorship, which means anybody who gives money in the name of the academic sponsorship, it goes right to Resilient Coders, and they get some shout outs, right? Because the conference is doing fine. It's not like we need lots and lots of extra money, right? We want to put this back into the community where it belongs. And I dig the people there. The other thing I mentioned is SOPA Telemetry. Go check it out. Around that topic, I'm going to be doing a conference called Observe 2020, slated for April 7th, and that will be at the Keller Room. Any kind of observability? Who knows the term observability? Right. In just production or test environments too? Wouldn't it be nice to have distributed tracing in your test environments too?